Hiya. You're looking pretty amazing today. No, seriously, you are. You're this bundle of hydrogen and carbon and oxygen and loads of other atoms all screwed up together in such a way that the result, quite frankly, is pretty amazing. In fact, you are an awesome being, sat there making sense of the world around you, staring back at me on the other side of YouTube. You are truly amazing. You are alive. And here at Beyond First Aid, the home of the highly skilled death dodgers, we'd like to keep it that way. Here at Beyond HQ, we think that to be the best at fixing the broken, leaking, and those who, for whatever reason, are no longer in a state of homeostasis, a good first aider not only needs to know how to stop the bad from being bad, but also why we do what we do. To be the absolute best, they need to have a basic understanding, at least, of what is actually going on inside the sick and injured that they may be presented with. Obviously, I want you to know that it's bad if your hand is leaking red stuff everywhere because your latest attempt to remove a stone from an avocado went seriously south. But why is it? What is that red stuff? What does it do? Why is it so important? And most of all, what does someone have to do to stop the flow of the sticky redness? We're going to learn about the different types of pipework you have and what blood does to actually earn its place inside them. Eventually, we're going to learn about blood and the circulatory system in detail, but baby steps. For now though, take it from me, blood is quite important. Breathing, this is also quite important. Depending on your age, fitness levels and your activity, what you're actually doing at the moment, we will find ourselves breathing between 17 and 18,000 times per day, and for good reason. All the cells in your body need oxygen. It's the respiratory system that pulls the air into your body and then squeezes it all back out again, but not before it's dumped a load of oxygen on the couriers for distribution around your body. We're also going to need food and water. But whose idea, who had the brainwave of putting the goods in and the ventilation system next to each other? You see, in the human body, the air tube and the food tube are right behind the face holes. This can cause us problems. Now then, your food pipe or digestive system takes all the stuff you shove down it and turns it into a form that our cells can use. When this has got broken down enough, the good bits are passed on to our couriers, and what's left carries on through your food pipe to emerge lower down. Once delivered to the customer, this food stuff gets broken down in the presence of oxygen even further into something called ATP or adenosine triphosphate. Very important stuff. It's energy producing, it's our currency. But can't the cells just use food, Steve? I'm glad you asked. No, broken down food, or carbs if you like, are like euros, still currency, just not ours. We need to convert the euros into good old sterling. Once we've got plenty of sterling flying around, our cells can do just about anything. However, this currency conversion process creates waste. This is in the form of CO2, carbon dioxide, heat, water. Anyone who's ever done a fire warden course may think this sounds familiar. Fuel, heat, water. Take away any one of those and the fire goes out. The same happens in us. Back to the couriers. What are these couriers? Red blood cells. Our blood is like yodel. Actually, no, it's not. It's nothing like yodel. Our blood is like the post office. It transports and carefully delivers oxygen and fuely goodness to the customer. It then collects the waste products that the customer has created, the carbon dioxide for example, and returns to sender. Now, the post office could not do this without a huge fleet of vehicles. What are these vehicles? What do the couriers use? Red blood cells, erythrocytes. Now, there's a word for you. Red blood cells are like jam donuts that have been squeezed gently to see how fresh they are. Like a polar mint with a hole didn't quite make it. Your blood also carries around an army of defending cells, leukocytes or white blood cells. Yes, these kick out the invaders. Then you've got platelets, which are pretty handy at plugging leaks in your pipes, along with a bit of help from fibrinogen or fibrinogen, depending on how you want to pronounce it this week. Over half your blood volume, about 55%, is plasma. Most of this is made up of water. You'll also find antibodies, which spring into action when there's an immune response. So you see, blood is quite important. It's got a very important job to do. Bleeding, or the loss of blood through, is bad news. Hemostasis. There's another big word for you. This is the process of clotting. It involves those platelets and fibrinogen particles that I told you about earlier. But let me take you back to that avocado on toast you were preparing earlier. These big fleshy pears have a huge stone at their heart. Whilst trying to get it out, you're stabbing at it with a steak knife. Can you see where this is going? One slip and ouchie. Avocado hand. Yes, this is so common it's actually a thing. Breakfast is ruined. Red avocados are not in vogue this week. Besides which, your blood is far better served running through your veins and arteries than it is splattered across your toast. Immediately upon the knife invasion, your blood tube is going to constrict, reducing the flow of blood through it. Chemicals will be released and your platelets will rush to seal off the damage. However, on their own, platelets aren't that good. Think bricks and mortar. Bricks are quite good, mortar makes them stronger. This is your fibrinogen. And over time, these particles actually pull the sides of the wound together. Healing. Job done. Now this is all well and good, but this only works on a small scale. You see, platelets are fairly tiny. If you think of a small stream, for example, if there's any obstructions in the stream, the crud that's floating on the surface is going to collect around that stream. It may eventually build up and stop the flow of water altogether. The pressure builds. This is exactly what the first aider needs to do. Apply pressure. Stick a plaster or dressing of some kind over the wound and the platelets can form a clot before getting washed out to sea, helped by that pressure. Now imagine that this small stream turns into a mighty torrent. That little obstruction you've applied may not do the trick. It may end up getting washed out to sea itself. You're actually losing a lot of blood quickly. So you're going to need a dam upstream, a tourniquet. A well-placed dam upstream or a tourniquet can stop the flow completely until the engineers downstream have figured out what the problem is and how to fix it. This is usually done by the people in A&E, or worst case scenario, you'll end up in theatre. But now everything has returned to normal and the flow can once again head off in the right direction, transporting all those goodies around. You, the first aider, just saved a life. Today's journey started when you took a breath. In your lungs, oxygen left the respiratory system and joined the blood, where it continued its journey through your body. Here it's joined by the fuel that your blood has also been carrying around, and the magic happens. ATP is produced. Energy. Life needs energy. And I've just given you a very brief description of how we create it. Food, air, water, all goes in. The waste air comes out the way it went in. The waste of everything else, fortunately, comes out somewhere else. We've learnt that blood goes round and round. If any of these things are not working properly because of the avocado hand, or maybe a cardiac arrest, or maybe choking because food went down the air tube, not the food tube. And if you're very lucky, you look up from your pool of blood and notice a high-vis jacket with Beyond First Aid written on it. You'll know you're in safe hands then. As they unzip their first aid kit and don a pair of gloves, they'll introduce themselves and save your life, obviously with your permission, because that's what we do. And I like to think we do it well, because we go a bit beyond first aid. See what I did there?